Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in.
Okay, so for this first question on the left, we have how much energy is transferred when 700 millicoulombs of charge move through a potential difference of 80 kilovolts. Remember, potential difference is just another word for voltage. So first things first, we need our equation. So that is E is equal to Q multiplied by V. And here, my charge Q is 700 millicoulombs. So I've got 700 times 10 to the minus 3 to get that into coulombs, multiplied by the voltage, which was 80 kilovolts. So I have got 80 times 10 to the 3 to get that into volts. And if I multiply those two numbers together, I get 56,000 joules. Okay, next question. How much charge flows through a bulb which has a potential difference across it of 70 millivolts and an energy transferred to it of 5 nanojoules? So again, my equation I'm using is E is equal to Q multiplied by V. And let me write out the variables that I've been given. So I've been given my voltage V, which is 70 times 10 to the minus 3 because it's millivolts. And then my energy is 5 times 10 to the minus 9 because it's giving me in nanojoules. So it's 5 times 10 to the minus 9 joules. And I'm trying to find my charge. So I take my equation and rearrange it so that I have my energy divided through by my voltage. So 5 times 10 to the minus 9 divided by 70 times 10 to the minus 3 gives me 7.14 times 10 to the minus 8 coulombs. Okay, now to try and find some missing voltages. So if we look at circuit number 1 off on the left here, very simple circuit. I've just got one cell and one bulb, and that cell is the only thing in my circuit, so it needs to get the entire voltage of my supply. So if my supply has 8 volts, then that bulb also has 8 volts over it. Okay, number 2 here. This time I have 2 cells in my circuit and one bulb, and each of those cells are providing 3 volts to my circuit. So in total, my supply voltage is going to be 6 volts. I've only got that cell in my circuit, so that needs to use all 6 of the volts. So the voltage over my bulb is 6. Okay, number 3, we have a supply voltage of 8 volts, and then I have 3 different components in my circuit that can use those 8 volts. So I've got my bulb that I'm trying to figure out the voltage over, I've got my motor which has 3 volts over it, and I've got my resistor with 2 volts over it. So together, that motor and resistor are using 5 of those 8 volts. So my bulb is left with 3 volts. Okay, and the circuit down below. This time I'm trying to work out the supply voltage, and I've got these 3 components. I've got my bulb with 1 volt, my variable resistor with 5 volts, and my resistor with 3 volts. So if I add all those voltages together, 1 plus 5 plus 3, that should equal my supply in series. So 9 volt supply. Okay, and question number 5 here, I've got 10 volt supply, which is being shared between my 2 bulbs here. And since those bulbs are identical, it is going to be shared evenly. So I know that each one of those bulbs has 5 volts over it. Okay, and voltage in parallel. So find the missing voltages. In step 1, we have, so we have an 8 volt supply, and in parallel, remember that voltage gets applied to each branch. So each of these bulbs will receive the whole 8 volts each. Okay, number 2. This time we've been given that the bulb in the first branch receives 6 volts, and we're trying to work out what the voltage is of the supply and what the voltage is over the resistor in the last branch. So since that bulb in that first branch receives 6 volts, and we're in a parallel circuit, which means that bulb must be getting the entire supply voltage, that means my supply voltage must be 6 volts. And the resistor in that final branch should also therefore be receiving the total 6 volts. Okay, number 3 here, so we've got 8 volt supply, and then we're told that these are all identical bulbs. So let's look at the top branch first. So in the top branch there is just the one bulb there, and that branch gets the whole of the supply, so that bulb gets all of those 8 volts. But then in the bottom branch there are 2 bulbs in that branch. Now, as always in my parallel circuit, the branch gets the total supply, 8 volts, but since there are now 2 things in that branch, each of those 2 bulbs get 4 volts each. I know that they both get 4 because that 8 is going to be split evenly because these are all identical bulbs. Okay, and in circuit number 4, again, we're looking for a supply voltage and we're looking for the voltage over that resistor. So again, if I look at my first branch, my bulb receives 4 volts. That's the only thing in that first branch, so that must be equal to my supply voltage. And then in my second branch, well, the whole branch gets that supply voltage of 4 volts, but that bulb has already received 1 of those 4 volts, which means my resistor must receive the other 3 of those 4 volts.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Okay, so my tips and tricks for this section. The first most common one is when you're dealing with parallel circuits. So basically the voltage is not shared in your parallel circuit, it is applied across each branch. So if you have a supply voltage of 3 volts, like in this little picture here, that next bulb receives 3 and the next bulb receives 3 and so on and so forth. That's the most common mistake that pupils would make, is giving each of those bulbs 1.5 volts. Voltage versus potential difference. You might sometimes hear it called voltage. You might sometimes hear the term potential difference. At GCSE, they are kind of interchangeable, but voltage is a slightly more umbrella term of energy per unit charge. And potential difference is when you're talking about the voltage over a component. So a potential difference of 1 volt over a bulb, for example. But for GCSE's sake, you can kind of use them interchangeably. Okay, total voltage as you add cells. Yeah, just a little note. If you're adding cells all in series with each other and all facing in the same direction, then you just add all the individual voltages up over those cells to get the total supply voltage. If you're using E equals Q times V, do remember to convert your charge into coulombs and your potential differences into volts or energy into joules before you use them in that equation.